All right, folks, we are officially recording. It's 8 a.m. on my clock, so we are game on. I will share my screen. Okay, so the first thing I want to do, Emmanuel had a bunch of questions for me, so I want to answer those for everyone in attendance. Let's see, so question A, adhesive between the materials like the CD, where should the arrow go and what view? If you look at it from the side, it could be interpreted as apply to an edge. Okay, so on this one, what I would do is put your adhesive in the exploded view. So if you've got the view turned in some nice isometric exploded format, you're probably going to be able to see the face that you
Yeah, I'm
actually
trying.
want to put the glue on. So that's how I would do that. And I would just put some note that says, apply 2 drops of item 6 or whatever it happens to be, and put a arrow down to the point of application, and that will cover glue. Let's see, question B, notes to hidden lines. Emmanuel, what did you refer to on that one?
Oh God. Um, it was not dimensional. It was like I don't remember, but maybe like an adhesive or I don't remember. It's not a dimension though.
Okay, as long as you're not dimensioning to a hidden line, that's all good. If it comes back to you, just ask and we'll go over it.
Okay.
Center lines to holes we see in perspective, like when we have the 3 holes on the can 120 degrees apart and you see it from the front.
Doesn't make sense the way I worded.
Yeah, I'm thinking that one's just kind of a judgment call. So if it helps with the interpretation of the print, put them in. If it doesn't,
Okay.
I mean, I would probably put them in from the top view, but maybe not the front view.
Okay.
So again, if it helps clarity, put them in. Okay, modified parts like the displacer foam that's cut from sheet. How do I show it's modified? I have to put modified part. Okay, so when it comes to the displacer foam, the way I would handle that is on your material note, I would say make from Lowe's part number 15099, because Lowe's part number 15099 is actually a 4-foot by 8-foot sheet. And if you say make from, then okay, you've got this little disc. We all know it's not a 4 by 8 sheet. Hopefully that's clear to everyone.
Do you want to show in the page the original purchased part?
No, I wouldn't. Not on that one.
Oh,
That would be like on a sheet metal part showing the original 4 by 8 sheet. You know,
so that's the question that applies to the Coke cans. Would you like the whole Coke can?
yeah, we talked about that one before. So those are going to be features at the assembly level, much like machining a casting. So,
Okay.
you know, don't do a full assembly package on those. What I would do is just put the material as Walmart SKU number, whatever it is,
Okay.
so that they know what to start with. And then probably put the overall dimensions as reference, because you're not controlling them. And then fully detail out all of the cuts that you're going to make and you are going to control.
Okay.
But you think about, if you do a full 3-page document on assemblies at the, or excuse me, features at the assembly level for the Coke can. I mean, you do the exploded view. What are you going to have? You're going to have just a can. Yeah, that's kind of a waste of a page. And your bill of material, it's only going to have one item on it. So it's kind of silly. Just do it as a single page.
Okay.
Okay. Can I put dimension on the holes that go to the CD measured from the center of the CD?
Because you said put the dimension that somewhere can measure from. So on the
Yeah,
you
that
need
one's fine.
okay.
I mean, that's a commonly done thing. And especially you get out in the real world, if you're going to CNC the part, that won't matter.
Okay.
Okay, so item F, two parts that come as a kit. For example, the wire crimp comes from the screw with a little cylinder. Different parts. So it's funny you should ask this question. What I would do is draw the parts you're going to actually use, put the material as whatever it is you're going to buy. And then, yes, if you have to throw the other piece away, fine. We actually did that on the F-15 engine. There was some part, I forget what it was, but it came as a two-piece unit. We only used one piece. And for every single engine, we threw the other piece in the trash. Not
Uh,
efficient, but we did it.
the okay. Let me reword it because what I really meant is when you actually need the other part. It's okay if you throw it away, but I need the screw and I need the the the, the actual crimp. I need for us two different parts on the product.
So you're buying an object with two pieces
Yes,
and using the parts in different places.
yes.
Uh,
I understand that in a business they will have their own thing how they will do it, but
yeah, I mean, that's kind of an oddball situation. I mean, if I was going to do that in a real business, I'd probably buy the part, separate it, give the two pieces individual part numbers, and put them in their own inventory bins, something like that.
okay,
So if you're going to do that, I mean, just do something smart with it. If
okay.
that's the case, then fine. That's all good. Uh, need to dimension a small part in the final assembly, but it's hidden. Yeah, that's fine.
Okay.
If you have to do a detail in a section or something like that, that's fine. Center marks and center lines to hidden holes. Uh, yes, as long as it doesn't get so busy that it makes the print unclear. Clarity is first and foremost. So like in that alternator, we had a bunch of cylindrical surfaces inside. And if you turn on center marks by default, you get like 50 center marks that show up and it's an absolute mess. So if it adds to the understanding, fine. Uh, I make a plane normal to a line, even a curve. Okay. Yeah, the whole make subassembly flexible. That is a thing in SolidWorks. It makes my skin crawl. I hate that. A part number should have a fixed geometry. I mean, one part number, one shape, one form, fit, and function. Done. End of story. You start getting away from that and things get really weird. So we will talk about how to do that um, with configurations. So for example, you might have a backhoe and you might have three cylinders, all of the same part number with different lengths of hydraulic cylinder extension. That's a legitimate thing to do, and you handle it with configurations. Uh, and we will go over that in a couple of weeks.
Quick question back on the adhesives question.
Yeah, shoot gauge.
So when we're talking about noting that, would you want to like note that in like the top left where we note materials, where we'd also where you'd be like adhesive between parts 3 and 4? Or would you
Uh,
be noting that as some sort of,
I would note it in the exploded view. So you're
in
going to
like
have,
what way? Like that was my question there. Like what way are we noting it?
how about if you hold on to that question? I'm going to talk about bore charts for just a few minutes real quick, and then I'm going to get you guys started on 2 examples. And we'll do an explosion, and I'll show you how I would do a glue note.
All right.
Okay. Anything else on that, Emmanuel, that you wanted to hear about?
No, thank you very much. You covered all.
Okay. Okay, guys. So today we're going to do lesson 19, bore charts, and then we're going to go on to some more assembly drawings. As I thought about it, I decided that rather than risk having a second exam for doing the assembly and drafting stuff, I would give you a couple of my old exams as homework, and you can see what an actual previous exam looked like. Okay, so bore charts. When you go out in the big world and you're high paid, high power engineers, a lot of times you're going to have something like a base plate or a side frame that's going to have a whole bunch of holes to mount all of the sub assemblies and all the stuff that goes in your machine. And you could have all these holes and you could spend days just dimensioning out hole types and hole locations. And it gets really busy really fast and it's just painful. Like in this example drawing that I did for you. Okay, but there's a much, much easier way to do it. And that's with something called a bore chart. So rather than dimensioning all this out, what you're going to do is you establish an origin, you create a bore chart, and it gives you the location in X and Y, and then the type of hole. And it looks just like this. So let's go through and demonstrate one of those. So if you want to click along, download, let's see, download baseplate from lesson 19. And you can try this with me if you choose. Okay, and here's my imaginary base plate with a whole bunch of holes in it, all kinds of different types. We got a counter bore hole, countersunk hole, we got a uh, pipe tap hole, a couple of quarter 20s, we got a slot. And now let's make a drawing of this thing. I'll choose my piece bar drawing. And I get my usual messy views. Well, we can fix all that. Drag this down. Let's see. Drag that over. And I think I'll project a top view off this thing. And I'll save it. Okay, so if I want to have all of this stuff annotated for me in a nice, easy fashion, I'll click on Insert, Tables, and we'll come down to Whole Table. Whole Table, Bore Chart, it's the same thing. Okay, so first off, we're going to establish our XY origin. So I'll establish my X-axis right here. Whoops. We'll choose edge 1. We'll do the Y-axis. And you can see the start of an origin. And then we have to choose the face that we want to get the data on. We'll choose this face right here. As soon as I click the green check, it gives me this very nice little table. And that is all of the holes that I need to put in as measured from right here. And this is pretty slick. This is the same thing that you're going to get with the hole callouts. So for example, you get the tap drill size for your quarter MPT, get your tap drill size for your quarter 20s. So I know some of you guys are still enamored with the idea of cut extruding circles. And I still say it's a terrible idea, but let's try it and let's see what happens. So let's
Doesn't
go.
show up.
It shows up wrong.
Oh,
Even
okay.
even when you put the thread feature on, it shows up wrong. Okay, so let's see, we'll go back into our base plate.
A1 is a slot.
Yes.
How it shows the slot? It says that it's a slot.
Yeah, and again, this is why I generally don't like putting in slots as whole wizard items. Because if I was going to do this slot, the way I would do it is I would come over from this edge. I'll choose the slot option. So I choose the origin of the slot, and then I would go the length of the slot. And that makes far more sense to me because this will tell me where to start my cutter at, and this tells me how far over to go. And
Wait, sorry.
I can just set the digital readout to give me that.
Does that give you the slot radius on the chart?
Let's see. So A1.
0.25?
Yeah, so it's going to the outside ends of the slot.
Professor,
Yes, sir.
could you go over one more time how you got that chart of bore callouts?
Sure.
Thank you.
Okay, so the slot does match the call out up here, but they never really gave you the origin of where to start the cut at. So you got to watch the slots on that one. The holes are generally not too bad. Okay, so let's get rid of this. And I'll show you guys one more time how to do this. Okay, so once you've got all your views on your drawing, we're going to do what SolidWorks calls a hole table. So we'll do insert, tables, and hole table. First thing you're going to do is you're going to establish an origin that you're going to measure from. And that's this datum right here. So I'm going to click in the x-axis, and I'm going to choose an edge for my x-axis. I'm going to choose a vertical edge for my y-axis. And then I have to choose a face that I'm going to extract the whole data from. And in that case, I'm going to choose this front face. As soon as I do that, I can hit the green check and I get my whole table. Okay. And it's just that easy. And note that you get indicators automatically. So everything's labeled A1, B1. So it goes by type. If these were all the same type, you would see A1, 2, 3, 4, 5. Works quite nicely that way. Just like down here, these are 2/4 20 threaded holes. So we have a D1 and a D2. The one thing I would say about this print right now, we have stuff under the revision block, and I told you guys never, ever, ever put stuff under the revision block. So what we can do is I'm going to hit Control X, I've cut it, and I can just put it on sheet 2. And that's the way I would handle it.
When you cut it, did it just remove all the spacing, the word that you just used?
The little indicators.
Yep. Oh, there they are.
Yeah,
They're
they're
invisible
there, but
when you're not scrolled over them.
yeah, my video card has them in white for some
Why
reason.
are they white?
I have no idea. So let's see if I can save it and reopen it.
It's because you'd selected all of them, and then no, because
That's interesting. I didn't see it do that yesterday when I was practicing the
can you
lecture.
click on one of those again?
Yeah.
Because I think you can change the color of the note. Can't you?
Probably can. You can change just about everything.
You can change the alignment.
Let's see. Trying to.
It says use document font on the left. Maybe it was set up for white color.
Because those aren't going to show up if you printed this off.
Yeah, exactly.
Mine stayed dark, and I just dragged mine from the sheet down to where it says sheet 2 instead of copy paste or something. So maybe that works better. I don't know.
All right, let's try that then. So if I just drag this back over to sheet 1.
It disappeared when you selected everything. Like when you, as soon as you cut the table out, it disappeared.
Yeah, it's still in white. I don't know what that's all about. Let's make the table again, see if we can.
Also, the question is if you redo this board chart while those letters are still there, or are they gone now?
Yes, they are gone now.
Okay. It's really hard to see.
Yeah, agreed.
You have the Quadro credit card, professional one.
I'm sorry, Emmanuel?
Do you have the professional card for CADWORK, the Quadro model?
I have a SolidWorks certified graphics card in this thing.
Well, I mean, it's a fairly low standard to meet, but
Well, I'm driving a $3,000 laptop.
true.
I mean, okay. For $3,000, I would hope you could. All right, so this time I just dragged it over.
And they're still there.
And they're still there. So, okay, it's SolidWorks being SolidWorks. So it does work. It seems to just, on my machine, it likes being dragged to the other page.
Can you show how to drag it again? Because my Solidworks doesn't let me drag it to the other page.
Okay. So in this case, I'm going over the four-way arrow and I'm dragging it down to sheet 1 over the sheet 1 tab. And that dropped it back on sheet 1. And now I'll try dragging it to sheet 2. So I've got it by the four-way arrows. I go over to sheet 1. Now I've got a little direction arrow and it dragged it over.
Oh, okay, I see. Thanks.
Okay. Okay, so let's go back to doing the cut circle example I wanted to show you guys and show you that it just doesn't show up right. So I'm back in the model. I'll put a sketch on this face. Locate my circle. And let's do a 1-inch hole. Okay, so we'll save that. There's my hole. I'll do a rebuild to try and refresh. Okay, so it did recognize and update the table. So we have a G1 entry and it says 1.00 through. And as I've told you guys, generally, if you cut extrude a circle and you're just making a simple hole with no threads or anything like that, yeah, you generally get away with it. Still not a good idea, in my opinion. But now let's get a little bit fancier. So let's throw some threads on this thing. So we'll do an insert. We'll go down to annotation and we'll put a cosmetic thread on that edge. So 1.25 inches. Again, I'm having trouble. I wanted 1 8 inch, but I didn't know what the tap drill size was. So I'm going to take 1.25 inch 7.
It gives you the options that you can tap according to the size of the hole, right?
Within reason, yes. So if I tell it I've got a 1 inch hole and I want to put a 1/4 20 thread, that tap would just drop like right through the piece of metal. So it's not going to allow that. So these are the options that I could actually put into a 1 inch drilled hole. And that's, if I had to cut that amount of material with a tap, I'd probably break the tap, but okay, that's a lesson for another class. All right, so let's save this thing. We'll go back to our table, see what it updates as. So it puts in a very awful note with lowercase, which is absolutely terrible. So we'll get rid of that note. And if we go over to sheet 2, notice it says G1 1.00 through. It never picked up the cosmetic thread that we put on it. So this line 9 is incorrect. And even if I update it and save it, it's still wrong. So again, if you're going to do any kind of a threaded hole, by all means, use the hole wizard so you get the correct annotations. And let's even try doing it more explicitly. Let's go over to our part. We'll get rid of the cosmetic thread. Let's put the thread feature on it, which again makes my skin crawl. And even that is not going to make it right. Let's see, thread. End condition up to selection. We'll go to the bottom. We'll do a size of 1 inch, 1 1/8 7. Wants an extrude thread, that's fine. Okay, so we've got this ugly, nasty thread. We'll save it. We'll go back to our other document. I got threads poking out of the surface, but let's see what it did with the hole table. And I still have an incorrect bore chart. So the bore chart never picked up that thread feature. So again, just make sure that if you're going to do any kind of threaded hole, use the hole wizard or your bore charts can be wrong. Okay, so any question on that, folks? It's a really simple function, but I see the capstone students spending a lot of time trying to do these complicated base plates when a simple bore chart would solve their whole world and all their problems.
Can we use this for if there's like just one hole in the part, or do you just want us to mention that instead?
I mean, personally, I think it'd be shorter to just dimension it.
Okay.
I mean, generally, I would say if you've got, say, more than maybe 10 holes, then I would start thinking bore chart. You know,
All right.
if you got less than 10, yeah, just do it out by hand and it'll probably look cleaner.
Okay. And I had a question about like adding my sheets, because whenever I try to add my third sheet in the part drawings,
Yeah.
um it's not the same sheet that it gives out. It's like totally blank, and it doesn't have that any description about the material. It's just like a blank sheet.
Okay. So let me demonstrate how to add a sheet on this example drawing. So I'm going to go insert sheet, and I have standard sheet size. I come all the way down. You should be adding this B size sheet 2 format that I gave you guys. And I'm going to say okay. Are you seeing something like this, Sanskar?
Nah, uh, what I see is it's totally like blank, and it doesn't have any borders or anything. It's just a normal sheet.
Just blank sheet of paper?
Yeah.
Okay. So once we get folks going on the problems for today, let's you and I talk about it. It sounds like either you didn't download the format and put it in your formats folder, or the format folder is not mapped properly. One or
Okay.
the other, something like that's going on.
All right.
So we'll have to get to the bottom of that.
Okay.
All right, guys. If there are no other questions, then I'm going to give you 2 homework problems for next Monday. And they are going to be 2 former tests. So in the,
2 pieces of your Jeep.
I got to tell you, they're the only simple geometry that really does a good job with exams. And yes, your exam I finished up on Saturday. And yes, it's more Jeep parts. I
We
mean,
have 40 minutes to finish it.
I feel like Abadesa just walks into his garage like a freaking kid in a candy store, and he's like, "Oh my god, there's so many good parts here."
you have no idea, Gage. So I'm on the 12 Jeep process trying to get over my addiction. My barn is huge and it's
12 steps to recovery.
way overpacked. I have one of every Jeep all the way up through 2004 and a couple of repeats.
Once you start a Jeep collection, you're not too keen on stopping.
Well, when I got my antique Ford tractor, I was like, no, this will not become an addiction. As soon as I got it, somebody offered me another one. I'm like, no, 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 no room to park it. All right. So that said, the two assemblies I'm going to give you is this universal joint and Jeep front suspension. These were two actual exams that I gave, I think 2 years ago. So download all the parts in these. You're going to do a standard 3 drawing package. So you'll do the assembly drawing and then do a fully detailed drawing of the cross and the yoke on this one. And then on this one, I had folks do, let me see, did the spindle and the brake drum.
How many minutes we have to do it?
So this was each of these was a full exam. So like this front suspension, that was 2 hours to do the assembly drawing and the two detailed parts. And you're going to have the exact same thing. I'm going to give you an assembly. You'll have to explode it, do the 3-page. I'll give you 2 components. Give me a fully detailed machine shop ready print for each. All right, so let's take a look at what these look like.
So you say the cross and the yoke and the spindle for detailed use?
Yes. So fully detailed prints of the cross, yoke, the spindle, and the drum. And then, of course, the assembly drawing. And what those look like, I'll show you this version first. If any of you guys are at all familiar with universal joints and how power gets from the back of the transmission to the axle on your car, this was a really nice little exercise. And what I told them in the exam handout was you are going to set the depth of this little bearing as a 1/16 of an inch below this top face. So that's going to be something that you control. You will control the pressing depth. Okay, but I did not give them this. This is just as background information. That would have been just unfairly hard. What I did give them was this. Same thing, but the straight version. And notice there is a little hole right here on this corner. So you're going to have to remember how to do true size views on angled faces. Okay, so that's the first one. And then the second one,
So we're not doing the bent one, correct?
correct. Only the straight one, Sam. Let's see. Okay, and here's the other assembly. So you've got the blue thing, that's the spindle. The purple thing is a ball bearing. There's another ball bearing in yellow inside. Let me just slice this thing. There. Now you can look inside. So the way that a two-wheel drive car's front tire is held on, you got this spindle, there's a bearing here, bearing here. This nut squeezes the two bearings onto the spindle, and the two bearings support the outer brake drum. This green thing is a nut, it's called a castle nut, and you drop a cotter pin down through it, and that keeps the nut from unscrewing and the wheel coming off. So again, you would do a fully detailed drawing of this blue thing and this orange thing. And I always give you guys instructions before the test. So for example, I gave this handout with the suspension problem.
128. I'm glad you upgraded to CATA files.
Well, I was thinking about catenators for next year. I don't know. Let's see how dominating they are. I call my Crosby workers Crosbyites. Okay. So again, you can ask any question you want about what is this, but I don't ever want you to question, do I have to have background knowledge to do the test? No.
Quick question: what is that on the right?
Uh,
Oh, sorry, not on the right, on the left. I mean,
the pink Jeep.
yeah, it's gross. But continue.
So that was actually a DJ3A. These were common mail carrier and resort vehicles in the 1950s. The thing about these is they were two-wheel drive, which was unusual. Most of the CJ3As, like the one I have, they're all four-wheel drive. But yes, it was gross. And yes, they were all in this ridiculous pink with striped upholstery. They made thousands of these things.
I see it coming like stuff like pink and yellow.
Oh, don't make my brain hurt, Gage. That combination is just awful. All right. So anyway, but it did make a good test. And one of the things I'm going to be looking for on the exam, one thing I get absolutely crazy about is don't push metal through metal. When you do your exploded view, make sure that the explosion goes in the direction that you would actually install stuff. So for example, on this one, I messed with people, and this back purple bearing, this has to come out the back, and a bunch of people were pulling it out forward. Okay, no, it doesn't go in that way. So go ahead and get started on this. And then if you guys run into questions, we can do it. This one was also a good example because the brake drum with the studs is a sub-assembly. So you're not going to see the studs or the brake drum show up in your bill of materials. You'll just see assembly, comma, brake drum.
Oh, okay. I got really confused by the question there for a second. Then I noticed that it was just talking about that wheel assembly you have.
Yeah.
Because at first it said design the package for a front suspension. I was like, so do you want us to like get the coils and stuff going too, or
No,
I
no,
was like, do you
no,
want struts and stuff?
no, God, no. No, I have to be somewhat merciful on you guys. No, just the thing that's in the parts that I give you. So on this pink abomination, the blue thing just bolts right up to a solid front axle.
I have a question on the final project.
Yeah, go for it, Ryan.
How do you want us to model the connection between the balloon and the crankshaft?
So on that one, I'm not quite sure how to answer that. So I have my yellowy colored balloon right here. And I put a hole in the center. I've got my bolt coming up through it. I've got this nut, or excuse me, this washer providing somewhat of a gas seal. I've got my curly push rod, and that goes up to the crankshaft.
Quick question about your cans there.
Yeah.
What did you do for connecting these cans here? Those are 2 cans, right?
Yes. I just pushed them together and let them be an interference.
Oh, okay.
So in the real world, yeah, the bottom can would bulge out and go over the top can.
The way things are poking out, I thought the way things are like poking out because they're like intermittently poking out. I thought you like stitch welded your own can. I was about to say, wait a minute.
No, no, no. Again, not going to be that merciless on you guys.
So when you spin the crankshaft, what happens with the balloon?
So right now, nothing on mine. I've got my mates a little bit screwed up right now.
So it's okay if it doesn't spin?
Well, I would encourage you guys, get the crankshaft spinning and make this push rod go up and down, and then be able to look inside and watch this displacer and make sure it's not hitting right here or on the top of this dome in the bottom. Once you've got those dimensions set, so it's going up and down and not banging, then yeah, do the mates for the connecting rod out here.
Okay, I see. Thank you.
And then it will lock up and you won't be able to turn it.
Wait, so what did you do for the balloon portion there?
Oh, I got all kinds of crazy. I went way more fancy than I want you guys to do.
Yeah, I looked at it and I was like, that looks like a cap. It doesn't even look like a balloon.
Yeah, no, I just want you guys to do an L. Because if you guys handed me this, I would say, okay, you got to do a fully detailed blueprint of that with all the folds and the location of the folds and all. Don't go there. That's way too hard.
So like just flatten it
Yeah, so just have this vertical sidewall and then come flat across
and
the
just sort of
top.
fill it at the edge? Or is that not necessary?
I wouldn't even say that's necessary.
But you say that import parts that already bought, already made, we don't have to put details or everything. So
Correct. So like the purchase part drawing for the elbow, I mean, I would put the overall maximum height, maximum length, maybe put the two holes as reference and call it done.
How about for the soda can?
That one, don't get crazy on it. I would probably have the height and the diameter as reference, and that's it. You're not controlling anything. You're not inspecting anything.
I had a quick question as well about what your sorry, I'm trying to think of what I'm trying to say here.
That's okay. It's an 8 o'clock class. We allow that.
I'm not awake yet, but
I hear you.
your coiled thing there. Fuck.
Connecting rod.
Connecting rod. Sorry, I just spaced that hard. When you had that cut in half, it looked like it went through stuff.
Yes. And you can control.
Like it's going through the washer.
Yes.
Should we try to avoid things like that?
Yes. Yeah, my layout's pretty messy right now. I would want to see you guys do it as the coil starting on this face and ending by the upper face. So
okay, so just like 2 coils.
Yeah, that's all you.
Two. It only needs 2 revolutions to get around.
Absolutely. Yeah, that's all you need.
Because by the third one, it's halfway inside your washer.
Right.
Well, the first one's also halfway inside your washer, but
yeah, this is absolutely not necessary. I mean, even if you wanted to do, you could do some kind of a slick U-bend and then just squeeze it with the washers. I'd be totally fine with that. I mean, that's not going to come out.
I have a question about one of the homework problems.
Absolutely, Sam. Which one?
I forget what it's called. The one with the cross and the yoke.
Okay. Yeah, the universal joint.
Do you mind if I share?
Yep. It's all yours. Nice.
Sorry, it just took me way too long to figure out how to unmute there. Yeah, is this kind of what you're looking for?
That's exactly what I'm looking for.
Okay, because I wasn't sure how it fit in here because it seems like it's too tall to just go in there.
It is, and what you got to do is you got to rock it to put it in place, and then you press the little caps on the ends. But
okay.
Don't worry about anything exotic like that. What you're giving me right now, perfect. That's absolutely fine.
Okay, so with this line, I wasn't sure what to do because we haven't really done face-to-face. We've mostly just done holes.
Right.
I just did like a construction geometry and then
perfect.
Put it to the middle of that.
So, okay. or the other thing you could do is you could go hole to hole, go from the top of the yoke,
okay,
or the yoke hole to the cross hole, or I said that wrong. The yoke hole to the top of the cross boss, little round section of it.
Like over, like this, or.
Now look at the top. Look at the top round section of the cross. That very top, that topmost face. There you go. So if you went from there over to the yoke where it's going to go in. No, other direction, other side.
Oh, okay.
There you go.
That's kind of at an angle, but yeah, okay.
Yeah, I would go to the bottom hole, the bottom of that same hole. You could do that
okay.
too.
I have a question on this design after you're done, guys.
Okay. So just my last thing was, I would need to do lines for the top and the bottom, right?
Correct.
And then how would I do this one? Could I just do from this hole to this hole? Would that work?
Yeah.
Or this face to, I mean, in my view, like you'd have to rotate, like do a different view to get it to look really nice, but.
And that's fine. And that's kind of why I've stopped using this example. It's fine as a homework. But yeah, you got to rock the cross into place, and it wasn't totally clear.
So like, it doesn't seem like these holes are lined up really, because it wants me to go
Yeah.
up here.
So what you do is you light up the edge first, you hover over the edge, and then you should be able to see the center. There you go. Good. Just like that.
Okay. So then once I add these two, that this will be good with lines.
Yes.
Okay. Thanks.
The exploded lines on this exploded view, the sketch lines should be, they should be going through the holes of the yoke of the. Can I show you my screen to explain something?
Sure. Absolutely.
Dad, can you fix my internet?
Wait. So these lines, did I do it right that they go like that? I mean, it's similar like the yoke. Instead of showing that this crankshaft goes straight from here, I'm showing that goes first to the hole, it goes up, goes here, goes down. This is something we should do with the yoke as well.
Yeah. I like where you're going with that.
Maybe it's not, the design is not a good view, but you know what I mean.
Yeah. That one, I'm not going to get all crazy over that center connecting rod.
Okay.
Because yeah, you got to wiggle the crankshaft around to get it into place and all that other stuff. And
I'm just saying,
even if you just had it straight out from the hole and just gave me a line that says the end of the crankshaft goes into this hole, fine.
Okay. Okay. Trying to stop sharing. Stop.
Professor Vanessa.
Yeah, Laura.
I had kind of a logistics question.
Okay, shoot.
I usually come to these lectures and labs if I'm awake on Tuesday morning.
I generally come if I'm awake too, but that could be not often the case.
But I'm in the other section.
Yep.
For homework, what schedule should I be following?
What schedule should you be following?
Because I usually go to this section, but I'm technically in the other section.
Yeah, I'm trying to keep you guys doing exactly the same stuff with the exact same due dates.
Okay, I just noticed that like a couple of them are weird. Like once we have like the day off and then Thanksgiving.
Yeah, we do. We get out of sync then. Yeah, because I couldn't do the material at the same time. I mean, what I can probably do is just, maybe I should just tell the graders, just accept the homework at that point.
All right, thank you.
Yeah, good point. I think that's what I'm going to do, because the folks that have been up on the homework and doing it, they're fine. There's no issue. The folks that haven't been turning in homework, they're already sunk. So there's no damage or benefit there.
Okay, thank you.
Okay, guys, so we're at 9 o'clock. I will hang on if people have questions, or if you guys need to take off and go to your other classes, you can zoom out of here. Totally up to you guys.
Actually, what I have for the exploded line sketch thing.
Yeah, Ryan, go for it.
Is this the type of thing you're looking for?
That's exactly it.
Awesome. Thank you.
On that one, when you make the sketch, if you turn on hidden lines, like I think we're supposed to, it gets really complicated, really messy looking. Is that still what you want us to do?
So in the exploded view, you should not have hidden lines turned on.
Right, in the first one, on the first page.
Show me why it looks messy. It shouldn't look that messy.
Okay. Because it's not that bad, it's just kind of confusing.
Yeah, no, that's what I was expecting. So
Okay.
those overall dimensions you've got are reference.
Okay.
So those dimensions are set at the component level. They're not set here, but we're just saying how big this thing is overall. Now, the one thing I would say is rather than that right view, how are you going to tell me how deep to press those bearing caps? So I told you they were 1/16 of an inch down.
Yeah, I guess I could do a section view.
Exactly.
Okay. So I'm just overall a little bit confused about like the 3 pages. I'm
Okay.
just not sure about the first page, like what is supposed to be on there. I know overall dimensions,
Yeah. So
but other than that,
so page 1, I want overall dimensions as reference. And also anything that you have to locate. So when I gave this as a test question, I told the students, you got to press the little bearing caps in 1/4 inch down from the top surfaces. Try the other orientation. There you go. Hey, no, you don't want to go. Don't want
I
to
gotta
go
go
there.
like here, right?
Yeah, exactly.
Okay.
Much better.
Okay. I'll deal with that later, but
Yeah, perfect.
okay.
So now you've got a nice visible edge, and you can go from the top of the yoke down to the bearing cap.
Okay, so you mean like up here?
Yep. So zoom
But
in, grab a smart dimension, and go from the top. Go down one more. Whoops, maybe go down to the bearing cap.
is
Right
that
there.
right?
Yep, right there. Maybe I got that wrong. Maybe it was an 1/8 inch.
Close enough.
Yeah. It's
So
coming out 0.126, but that's exactly what I wanted. That's how you would say push the bearing cap down a specific distance.
okay, and like the location of this hole, that should all be included in the part, right?
Exactly. That'll go in the piece part print.
So I don't need to do a call out or anything for this.
Correct. Absolutely.
Okay. All right. So you said dimension anything that like isn't that you need to locate, but that doesn't include things that are like just flush with each other, right?
Correct. Yes.
Okay.
So anything you're going to set. So for example, with the nut and bolt example, I set how far the nut was up the shaft of the bolt. Okay. In this one, I'm setting the depth of the bearing caps.
Okay. And I just my last question before I headed out was I saw that email about checking in with the Sterling engine.
Yep.
And I'm signed up for sometime on Thursday. Just how is that meeting? Like, is there a Zoom link or something?
Yeah, we'll use the office hours Zoom link, and it's really informal. All I do is I say, show me your top level, and then I pick a few components. Typically, I say, show me your crankshaft, and I check that you make sure you have the right offsets for the displacer and the power piston. I make sure you got the 90-degree offset between the two bends. And then I just start looking around a little bit. And as long as you're on track, you've got a good model, you're good to go.
Okay. I've done some piece part drawings, and I've spent most of my time on just the actual modeling rather than the drawings yet, but
Right.
okay.
So as long as you don't get really behind with it, that's fine.
Okay, thanks.
I had a question.
Yeah, Ryan, go for it.
Can I share my screen?
It's all yours.
Okay. So, whenever I try to make the root lines to the thing, it kind of like bends it some weird way.
Yeah,
In
you're
case
doing the
somebody-
root line thing. I wouldn't do that for this exact reason. So I would X out of root line and just manually draw them as sketch lines.
So, okay, I'll try that again. Exploded line sketch. So do you not want to do that? What?
Yeah, I would not do root line.
So how do I do it instead? Because I thought you did insert
Okay.
explode line sketch.
Okay, so go back over to the assembly manager and go up to the configuration manager. It's that middle, go down to the left. It looks like a couple of, I don't know, a couple of pages in an assembly tree. Down
Oh, right here?
to the right, one more icon. There you go. Click. Okay,
Yeah.
so now expand that default.
Yeah, I tried to do some already.
Okay, so you got a bunch of exploded views. You're in explode view 3. Now expand explode view 3.
Okay.
Okay, so you do have a sketch. So let's click on 3D explode 1 and then right click and hit edit. No, I guess we're in it. Okay. So now go up and click on the sketch tab.
Yeah.
Choose your line tool. And you should be able to go from center of faces to center of faces. There you go. Perfect. Click. Now rotate your view so that you can see into that gray bearing cap.
Okay.
Rotate some more.
For some reason my Solidworks is going really slow right now. There you go.
Okay. Now grab the center of that bearing cup.
See if it lets me.
So you probably want to highlight one of those edges first and then you'll get the center.
Yeah. Oh, okay.
Okay, nice. That'll work fine. And now you're not getting all those jaggies and broken edges and
Okay. Yeah, that makes sense. And you said for this homework, we, do this whole thing out, the exploded view, make the 3-page drawing for it.
Yep.
And then we do the individual piece part drawings for the cross and the yoke. And
Yep.
then do the same thing for the Jeep, do a whole assembly, and then do the spindle and the brake drum for individual drawings.
correct.
Okay. All right, that's all I needed. Thank you.
Okay.
I have a quick question. In the so I did the exploded view and all of the sketch lines in the assembly, And then went
Okay.
through the drawing, did my first page, and then I cannot figure out how to do the exploded view in the drawing
Okay.
for the second page.
Show me your screen, please.
Okay, yeah, that makes. All right. So, want me to go back to the assembly or just here?
No, I think you're good there. So what you're trying to do is drop in the exploded view.
Yeah.
Okay. So click on Insert. Go down to Drawing View.
Mm-hmm.
Model. Wheel Assembly.
Yeah. Like drag it over.
No, double click on it actually.
Oh, there we go. That's
Okay.
what I was missing.
Okay, good. So show an explode or model break state. That's good. Okay, so what I'm not seeing that I want to see is there should be a named view for your explosion.
Yep, I forgot to do that.
Okay, so then let's go back to your assembly and
Okay.
create that named view.
Um,
So go down, see where it says drawing view 87, expand that. Good. And then on the wheel assembly, right click and hit open.
it's not.
Oh, because we're on the wrong page. Click on sheet
Okay.
1 and then you'll be able to do it.
Gotcha.
Okay.
Um,
So now let's re-explode this thing.
yeah, that's bad.
Yeah, you got something going on there. Expand that. Expand exploded view 1. So
that's weird. It was like acting weird. Maybe it could like, can you would I be able to show this one
yeah, go ahead
and
and hit
like
it.
delete those other ones? Maybe.
Yeah, definitely delete anything you're not going to use.
I'll just delete this one. That's not right. Okay. Well, that's not the right thing. How do I show it like?
So you're in an exploded state right now.
Yeah, but it's not. All right, I think this one. I think it was that last one because I got it right on the last try. There's 3 tries.
Okay.
There we go.
go. Nice. Okay. So spin the view around however you want it.
Something like that, maybe.
And just as an FYI, I would have that cotter pin going down into the hole on the blue spindle. Because you've got it going down, but you're not showing me where the cotter pin gets installed.
Right. So how would I do that?
So you could add another explode step and drag that cotter pin back in line with the hole. And the other thing, what you're telling me with those trace lines, you're saying flip the cotter pin upside down and then ram it through the installation hole, which, you know, that might be hard.
That might be a challenge.
Yeah.
Okay.
So anyway,
I need to add more steps to that.
Yeah. So just
cotter pin.
Right. So come off the bottom of the cotter pin, go into the hole.
Okay.
Okay. But that aside,
right.
Go ahead and orient your view however you'd like it.
Yeah.
Okay. Yeah, that looks pretty good. Okay, so right click in the graphics area, go down to view orientation. And then in that dialog, go to the second icon from the left on the top row. Up. There you go. New view. Good. Give it a name like my exploded view or Say okay. Then you can dismiss that dialog and save it. Okay, now close out this view, do the little X, and there you go. And that'll take us back to the drawing.
Yeah.
Now let's go to sheet 2 and drop in that exploded view. Okay, much better.
There you go. That's it. All right. Sweet.
Okay,
Thank you.
so other than fixing those little things, you're cooking with gas now.
Sounds good. Thank you.
Yep.
Professor Abadessa,
Sir.
when I open the wheel assembly, it glitches out for some reason, and the brake drum doesn't show on here.
Okay, show me.
Okay, I'll share real quick. Okay, so this is what it looks like whenever I open the wheel assembly. I don't know if you can see that or not.
Yeah, so for some reason it didn't load the brake drum subassembly. Try downloading again and reopen it.
Okay, I'll do that real quick.
Oh, there's the problem right there. Get rid of that one on the end of it.
Which one? Oh, this?
Yeah.
Rename it. Okay.
Nice. Okay.
That's
And then get rid of the 2 on the brake drum. It's going to have problems with that too.
okay, and like net 1 says this all here too.
And wheel stud 2, yeah, get rid of all those numbers on the end.
Okay. Okay, so that should be fine if I reopen that.
Absolutely. Yep.
Okay, awesome. Thank you.
I had one more question.
Yeah, go for it.
When you are putting like the line to show or the path line for the yoke to go to the cross.
Yep.
Can you put it, or do you mind if I show mine?
Absolutely, go for it.
Okay, I need to open it real quick. Okay. One sec. I just put it like this. Is that all right? Top.
Yeah, that's fine.
Okay. All right. All right. Thank you.
Professor
Take a look at the.
Oops, sorry. Go for it, Ryan. I had my chance.
Can you take a look at the cross yoke that I did?
Sure, go for it. Take the screen.
Are there any dimensions that you think I'm missing?
Okay, so we've got that hole, and you've got it at 3/8.
Yeah.
You got 3/8. That's actually not bad. So I was trying to push you guys into having to do an aligned view to say where that hole is. But that actually looks pretty good.
All right. And then can you take a look at the
And make sure you put the material note on it.
okay, I'll do that. And I was also wondering on this one, is this dimension clear enough for you?
Yes, absolutely.
Okay, thank you.
Now, you're probably going to want to put it on the other 4 legs as well, or the other 3 legs.
Oh, okay. I can do that.
But other than that, you're good to go.
All right. Thank you.
Have you put a 4x to say that it's in 4 places instead
Sure.
of
You could put a suffix on it and say 4 places. Sure. That'd be clear.
How did you say to go about showing that the cotter pin needed to go into the spindle? I didn't really catch that part.
So what I would do is, in your initial explosion, I would have dragged the cotter pin just straight up
Mm-hmm.
and then draw the line down to the installation hole.
Just down to the other line for the like
Yeah.
for the when the spindle comes in. I don't have to like show like that the cotter pin goes with the spindle and then drops down in.
No, that's getting too complicated. If you guys
Okay.
just show me the cotter pin goes in the proper installation hole, I'm good with that.
Okay. Alrighty. Thank you.
Last question before I go.
Sure, Emmanuel.
On the next lesson, I cannot activate the real view. Do we really need it?
No, no.
Okay.
Even when we get to the photo rendering lecture, a bunch of people aren't going to have real view because of their video cards.
Yeah.
That's totally fine.
Okay.
I go over it, but it's just to show you guys what you can do.
Okay, thank you.
Okay, thank you. Anybody else have questions out there?
I think I'm all set. Thank you.
Okay, thank you. All right, so if you guys are all set, you don't have any questions, I'm going to end the lesson and try and start heading in all this snow. I'll catch you guys tomorrow. Bye.